Okay, we are here. We started creating where we are. Okay, we are here. We started discussing about these things, whatever. Okay, now where we got stuck yesterday was we were unable to link and then compile and link. That is something which did not work yesterday. The reasons are one of the reasons was uh, from Go version 1.20, certain things got changed. Certain things got changed means there are some archive files. Go generate some archive files. If you really look at it here, let me go here, user local go pkg, then Darwin. These are all archive files, .a files. For the linker to work, for the linker to work, it has to link all these R5 files, or it has to link few archive files. The linker has to link few archive files. Okay, 1 minute. Someone will join. The linker has to link archive files, but version Go 1.20 onwards, it stopped. By default, it stopped creating these archive files. So what I did is there is a flag that go debug equal to install go root all. When you enable the flag and then you recompile your std standard library, because all the runtime and everything is in standard library. I did a lot with go install std, but it didn't create these archive files. Go install std. Whenever you type go install std, sorry, wait a minute. Whenever go install std, it recompiles the standard library. You know that there is a standard library. Go has got a standard library. That standard library is over here. src in your Go installation. You go to Go installation. Go, where is your Go installation? If you type Go env, wherever you see Go root, wherever you see Go root, this is supposed to be your Go installation. This is where actually Go install. There is an environment variable called Go root. We have seen other environment variables, something like Go arc, and then we also see Go OS. Like that, there is some environment variable called Go root. This is the root directory of your Go installation. Whenever you install Go, it takes you to it. This is the root directory. All these environment variables are set. You can change the directory and then you can change. You can keep the directory elsewhere, and then you can also create a change the root directory as well. That's fine. There is no issue at all. But this is the default root directory whenever you install. Whenever you find this Go root, there is also other directory which is called Go path. Go path is the directory where there are two things: the old versions of Go before version 1.11. Wherever you are creating a project, you have to set the project as your Go path. You have to add the Go path to that particular project. Ever since Go module came into the picture, I told you Go modules were not available before version 1. Prior to version 1.11 of Go, but all I think almost for the past 2015-16 onwards, Go mod is there. 16 or 17 onwards, Go mod is there. Go version 1.11 onwards. Current version is Go 1.23. Ever since Go mod came into the picture, then the way how the project structure has to be got changed. You don't need to set up the Go path explicitly. But this Go path is used whenever you use third party libraries, whenever you create your own packages and all, your own libraries or packages, it uses this Go mod uses this particular Go path. You don't need to do anything with Go path, but you can go and check what are there in the Go path. But usually you don't need to do anything with the Go path. And the other thing is Go root. Already I discussed it. The third one is called Go bin. Go bin is also very important. Go bin means whenever you call Go install, what it does, it installs some tools. Let's say that uh, whenever you install Go language, you can see that Go install or update tools. You have to do this. You go to command palette in Visual Studio Code, type Go install and update tools. These are all the tools that gets installed. These are all the tools that gets installed. You see that it installs all these tools. So what are these tools? Go paths. It's a language server. Go test. It is used for the test. Go modify tags. Go tags is a separate thing. Go implementation. It is also kind of a linter. Go plays for playground. DLVs for debugging purpose. Static checker is like whatever you write code, whether it is a correct code or wrong code or giving warnings, uh, naming conventions, coding standards, everything is done by static checker. These are all the tools. Gopals is PLS is very very important tool. It's a language subject. All the help, whatever you type and all, everything comes through this GoPLS and then stuff like this. This with this. There were around 11 tools. I think they got merged and then now there are only 7 tools. These 7 tools are very important for code. DLV is for the debugging purpose. Delve debug. So how these tools are installed? All these tools are available in github.com. You see this. All these tools are github.com. Let's say I copy this. I go to terminal. I say go install and then give a path like this. Go install and path like this. There is, as I said earlier, there is a bin directory. Where is the bin directory? Go env. Bin directory is used for all the binaries. Binaries that are Go related binaries. What are the binaries that you create? When you use a command called go install, automatically all the binaries are stored in a bin directory. That means there is only one directory. If you set up the path of that particular directory, automatically the variable, the all the tools are available in your entire system. This path is set like user bin path. User bin path. You don't all the tools in your Linux or Unix machine are there set up in a path called user bin. If anything you drop in user bin, automatically that is available everywhere in your terminal. Any path from any path you can call them. You don't need to set up a special path for any of the Linux command because all of them are there in user bin directory and then the path is set. Similarly, all the tools that are required for Go are stored in Go bin directory and the path is set for Go bin directory. If you don't specify the Go bin directory path, it's not specified here. There is no Go bin directory path. Automatically, Go path is taken as a go bin path. It takes go path as the go bin path. That means users Jiten go. If you really go here, users Jiten go. There are two things here. One is called bin, other one is called pkg. I go to bin. See all the tools that are installed here over here. Let's say I delete DLV. I deleted DLV. I deleted DLV. I go to my terminal and then I say go install join. I go to my terminal. I say go install from this path. This is a GitHub path. That means even you can write the Go program and push it to your GitHub location and then use that path to install. From there, it gets installed automatically. From there, it gets installed automatically. Go install. When I click this, it pulls from this particular path as long as it's a public path. It's a public repository, and it gets copied to this directory. You see the delve is copied in the bin path. Let's say I go to my program, one demo, first demo. I say go install hello.go. It's not a path. It's I'm calling go install from my path. When I say go install hello.go, it came here into go bin. That is what go bin is. Particularly for the linter, CI/CD pipeline, and any automation. Actually, for automation, they use this go install a lot. You download different tools and then you set up go path and you run this go like anything. I mean, this very useful, particularly for CI/CD, and not only that, it's pretty easy to install. And then the other thing is coming back to that linker. The linker has an issue. Coming back to the issue what we had in second session, yesterday's session. I would like to compile my Go application and link it. Two things: compile. You don't basically you don't need to compile and link, right? You don't need to compile and link. When you run Go build, automatically you get the binary. This is the binary. That means compile, assemble, and link happens like any other compiled programming language, and you get a binary over here. This is the binary. But we would like to verify it, what all the things that are happening. You can also verify it. Let's say there is something called go build. There is a flag called X and there is a flag called V verbose. It clearly tells that what all things it has done. You want to see that what all things, how build go build with the details. You use this flag. It clearly tells that okay, where it has created a temporary folder. This is considered as a work folder, and then it has created a file called this link file, import cfg.link file, and then it linked all this. That you see that everything got linked over here. It created a build ID. It has linked all these files. And then ultimately, when you come down towards it, there is a guru go to link. It is using the link and then it is saying output of this a.out file. You can give any extension and ultimately it generates the binary. This is the output file. This is the output file. After the linker links, what it links everything, whatever the import config has got. That means all these things are linked. And ultimately, it is changing the name a.out to demo. And this particular demo is deleted from here and copied here. It copied to the current path. You see that it's moved from this path to current path as demo. And it has deleted the temporary directory. So that's where we got demo. So here compile happens, link happens, everything happens. We are not doing it. The Go build tool is doing it. You can also compile it. How do you compile? Go tool compile. The output is hello.object file and then hello.go file. I removed that greet thing. Sorry. Sorry. You see that the object file is created. This is a machine code that is created by your compiler. When you compile, it creates a machine code. Just with the machine code, it doesn't work. As I said earlier, there is a linker. Linker has got its own process. It has to link. You can directly use LD linker. But when you use LD linker, which is a system defined linker, when you use LD, you need to know what has to be linked. As I said earlier, Go language has specific things you need to link for Go language. So whatever it has to link, if you use Go to link, the output is maybe hello bin. This is output file, and then you got to link hello.o. This link, it links hello.o, and since it is a Go linker, not the LD, it is a Go linker. This links all required archive files. When it can link whenever there are some archive files. When there are no archive files, yesterday the problem is version Go.20, it was not linking. It was not linking the. It was not generating the archive files. They got changed. They changed the way how things work. But from the that is the reason I went and then ran this command. Go install std. As I said, std is a library, standard library. Generally, std is called as a standard library. Standard library is nothing but that is shipped along with your Go. Where is the standard library? If you go to user Go root directory, local Go, src, the whole thing is the standard library. This is the standard library. You have fmt, you have maps, there is a map, there is a net, there is a runtime. Everything is a standard library. Bytes, buff, IO, built-in package called debug, embed, image, HTML, hash, index, all this net, OS, path, plugin, these strings, strconv string. This is a standard library of Go. Whenever you say Go install std, it compiles the standard library and generates archive files for this particular Darwin. This was not created yesterday. Since it was not created, we got an error. The linker was not working. The reason is the latest version you have to enable this. By default, this is not enabled. You need to enable this. Go debug is equal to install go root all. If you put this flag, I had to read the Go documentation for this basically. No help was given anywhere. I carefully look at the Go documentation and then I think go install help, go help install or something. So, see, you see this. Starting in Go 1.20 version, the standard library is built and cached but not installed. I caught this. The standard library is cached but not installed. Setting up go debug equal to install root all restores the use of this particular standard library. Go root, that means this path. PKG is a folder, and goose, go OS underscore go R. This is the go OS underscore go R. It is compiled to this particular directory. By default, it is not happening. If you want to make it happen, you need to set this because everything is cached but not actually stored in this particular directory. Everything gets cached to the other package. There is a cache directory. This was the issue. However, so we observed that how to compile it, create an object file, and then how to link it and then generate a binary. So I typed hello bin. Sorry, some choking. This is where the hello bin is. Okay. Any questions here you have? I'm moving to the next demo. So I create mkdir variables, two variables. So far what we have done, we understand compilation process. Uh, we have seen couple of build options. We also saw how to minimize the size of the binary. Uh, we can remove symbols, LD flags. We can remove symbols. We can remove certain things, and then minimize the size. Symbols are very important for debugging purpose. So how can you bring down the size of a binary? Is always removing symbols, removing debugging information. We have done that by running one of the commands. Right. This command LD flags hyphen W1 hyphen S. Yes, the symbols. We see that LD flags, linked flags. For the linking flags, you are telling remove symbols and all. Okay, fine. And this you know that it reinstalls the standard library. It creates a package of the standard library. But latest versions, it is cached, but you want manually it is available, it should be available as archive in order to link externally explicitly because we would like to see how the linker work. So you need to enable this. Cool. Okay, now coming back to the next one, variables. Variables. So first step is go to this particular directory, go mod init demo. You can give any name, any valid identifier as the name of the module, but I just give as demo since they are demos. You can also give the GitHub path that I will show later on. So I'm going to, okay, I can write code main.co. I have a command called code. As I said earlier, if it's not working, code command, go to command palette, and type code, you can say shell install code command in path. It installs that particular command. If not, then manually you go and then create a new file and create main.go. You can create main.go or any file, but the most important thing is it should be inside the main package. Should be inside main package is important, not the name of the file. Name of the file could be of uh, anything. It's not necessarily to be main.go. It could be anything. The package main is important. That's how we are going to write something related to main, which is called package main. Function main is also important. This is where the execution starts from the developer's perspective. From the developer's perspective, right? How to create a variable in Go? What are variables? You have got numbers, you have got boolean, you have string. These are the general types. String, numbers, booleans, and all. Okay. Numbers are generally int. Int is a pretty primitive data type, but the size of the int depends on your underlying architecture. If you're running on 32-bit architecture machines, the size of int is 4 bytes. If you're running on 64-bit machines, the size of int is 8 bytes. So generally, most of the machines are 64 bits, so people say that int is 8 bytes, but it is not true. You can also have uint, int 8, int 16, int 32, int 64. Similarly, you have uint 8, uint 16, uint 32, uint 64. You know that what is u? Unsigned integers and all. Float 32 and then float 64 are for the floating numbers. So these are all primitive defined types. We call them as defined types or primitive types. Okay. There is something called rune and then byte. I will discuss about this. This also I put them in under numbers. There is a reason for that. So these are all integer types, and you have also something as a built-in type, which is I think uint ptr. There is uint ptr. It is specially used to store addresses because addresses are very long numbers, pointers. So you can perform. Can you do pointer arithmetic in Go? Directly you can't do, but indirectly you can do. Many people say that you can't do a pointer arithmetic. It's not true. You can do, but not directly, indirectly. So that means there is some way data type that should hold the addresses. Generally, addresses are quite big numbers. So there is a special type to hold addresses which are converted as normal numbers, which is uint ptr. So there is a special use for rune and byte. I will discuss this later. For booleans, there is only a type called bool. And then for strings, there is a type called string. This supports UT of 8 characters. String is nothing but behind the scene. Behind the scenes string is collection of characters, but these are UTF-8 characters. Okay, UTF-8 characters or or 4-byte characters. Each character is 4 byte. Unlike C language, each character is 1 byte, which are only ASCII characters. But Golang characters are 4 bytes. Not only Golang, all latest programming languages characters are 4 bytes. Other than this, there is a very interesting type which is which is interface type, empty interface, which is pronounced as empty interface in empty interface. Let me call this empty interface, which is interface or any. Both of them are same. Both of them are same. And before version 1.18, there was only empty interface, but later on they renamed it as any. So either you can use this or you can use this. This is the empty interface. This one looks pretty weird. So they created a data type, they something like any. It's not actually created, but they renamed it. I will show you how to you can also rename. Now, these are the variables, basic variables. To define types or primitive types, predefined types. You can call them built-in types. Basically, in Go, these are called as built-in types. You can write your own types. There is a kind of a type keyword, and then there is a way to write your own types. That probably we will have to look at it little later. But right now, focus should be on these types. If you want to create a variable, you have to use a keyword called var. Num1 as int equal to some number. Once you create a variable, you must use the variable in Go. If you don't use the variable, Go compiler gives an error. You see that declared but not used and not used, which is called num1. So if you create a variable, local variable, remember that global variables have different rules. If you create a variable, you must use the variable. That is a rule in Go. So num1 is created, so at least you print num1. Otherwise, it is considered as an error. Okay. So what is the size of int? The size of int is 8 bytes. See, int is a signed integer type that is at least 32-bit. We say at least. At least. It's not there. They have not said as 32 bits. At least 32 bits in size. That means it could be 32-bit or it could be 64-bit based on what architecture that you are running your application on. Okay. You can also create a variable where num2 as uint equal to some value. You can give minus values here, but uint unsigned integers you cannot give minus values. Okay. Like that, you can create var num3, which is uint8 equal to, maybe you can keep age, var num4 it could be float32 equal to some value, var num5 which is float64 where you're gonna give even bigger value, and then simply print this values. 3, 4, 5. This is how you can create normal variables and then store this values. Just printed value. Num4 is very big value, so there is a way to do this. I will explain it a little later. Floating point values. Whenever you are printing floating point values, there is a uh, printf statement from FMT package. Okay, you can do one thing. Instead of this print line, you can use from a package called FMT, formatted package FMT dot print line. It automatically import this particular package. It's a standard package. You don't need to give the path of a package. Even in Java or C Sharp and all, whenever you are importing using a standard package system namespace or a Java lang namespace, which are called standard packages, you don't need to give the path. You just need to import, that's all. Just to say that I'm going to use FMT and fmt.println, you got to print these things. We got printed. You can also use printf as well. fmt.printf, printf, formatted print like num1 equal to percentage p, and then let me put it as num3 percentage f, sorry, num3 is percentage d, num4 is percentage f, and then num5 is percentage f, and then you can replace these are the placeholders. You can have num3, num4, num5. The colon you don't need to give, compiler will keep a colon for you. You can give also, it's fine. That the IDE is removing it, but if you give also, there is no problem. Let's say I change this from Go to some text editor, then it's okay. You give colon. It's okay. You give colon. There is no problem. But if you convert it to Go, automatically this is deleted from this particular Go pulse. Go pulse does that for you. They say that you don't need to give. That's what I mean. I think if you want to put only two decimals, you can do like this in C language. I think in C language you can do, there are only two decimals, 0.2. This is very useful, particularly whenever you format. Uh, I will show you later on, but just for your uh, understanding, right? This FMT is a package. FMT package has got so many functions. FMT dot, append, scan, print line, scan, like that. There are append line. There are a few functions are there for the FMT package. So, right, these are all normal integers and floating point numbers. What about the characters? How do you store characters? There is nothing called char. So this is how you can create a variable. This is how you can create a variable where even without var you can create a variable. Let's say var num6 equal to maybe 45. This is called type inference. What does it mean? Based on the value, let's say var OK equal to true. Based on the value that it has got at the left hand side, automatically the type is inferred. But there is a problem. For example, you want to give the age. Let's say it is age. Age would not be more than uint 8. Age cannot be negative, so you use uint 8. So if you create like this, the type of the variable will be integer. That means you are wasting a lot of memory. Let's say fmt.println age percentage v. That means any value it prints, and then type of age is percentage t. It got to print the type of the variable. Okay, print line. Okay, just for the sake of this, I'm just putting okay. You see that? You sorry, it is printf. It's not print line. Mm, okay, new line. Otherwise, I can put a new line as well. This percentage t tells the type of age. So what happened is the this is taken. You see, int. Similarly, I take something called var float 1 equal to 12.34. Float 1, if you look at float 1 is only 12.34. Uh, it could be float 32, but it is inferred as float 64. That means there is a problem with that. Float 64 has taken. So whenever you let the compiler infer the type, particularly for numbers, Boolean there is no problem. Whenever you let the compiler to infer the type, what happened is compiler always for numbers infer compiler always gives the highest size. For integers it takes int, for floating it takes float 64. So unknowingly you may allocate multiple more bytes, not deliberately, but because maybe age require only the simple type, which is uint 8, but you let the compiler infer a type for you. That means during compilation it thinks it gives a type to this particular variable. Then what happened? It gives the highest size. But you may lose a lot of memory if it is not. For this is fine because it's Boolean, so there is no variations of Boolean. There is only one byte which is true or false. So there is no problem at all. And there is also this a type inference. Based on the type, the value is also inferred in Go, unlike some programming languages. Let's say that where OK2 is bool. I just printed OK2 is bool, false is inferred. Yeah. Let's say where num6 is u int 64. 0 is inferred. So default values are given to each and every type. If you don't give any value, a default value is given to the type. Really, you don't need to worry that what value, because in Java and all you have to assign a value. Even Rust you have to assign a value. Not only create a type, you should assign a value. Then only the compiler understand that hey, this is the type and this is the value. But in Go, if you don't assign a value, automatically it takes the value, default value. For numbers, the default value is 0. Let's say where num7 has float 32. When you print num7, sorry, let me put fmt dot print line, it gives a 0. given to the float. So there is 0 is given. So there is a type inference, there is a default value inference. There are two things. Based on the value, type is automatically taken, and then based on the type, value is also automatically given to the variable if you don't give any value. There is a shorthand notation which is many people use it. There is a shorthand way of creating a variable which is OK3 colon equal to true. But shorthand notation, for shorthand notation, a value must be given. Without giving a value, you really cannot create a, a variable. OK3 is what? OK3 is a Boolean type. So here the type is Boolean, the value is true. Automatically the type is taken based on the value that you give, and the type is Boolean. You know what is OK3? Percentage %v, and then type of OK3, which is a percentage %t, which is OK3 comma OK3. This is not a print line, this is a printf. So bool is given. You don't do things. The type is inferred, and this is a shorthand declaration of variables. This is a shorthand declaration of variables. You can also declare multiple variables. Let's say var. I can create num1 as unit age. I purposely gave num1, num2 as uint 64. Sorry, uint 64. Num3 as float 32. Num4 as float 64. OK as boolean. See that I can create a group of variables like this. And num5 comma num6 as int if the type is same. Then fmt.println, I just put num1, num2, num3, num4, num5, num6. Okay. So here the problem is there is no, already num1 is declared. Already num1 is declared. Num2 is declared here. Okay. I'm not printing it or what? Okay. Okay. Num1 is declared. Num2 is declared. Already declared. There is a concept called shadowing or something. If you want to redeclare the same way, what we are not short of variable names. First of all, absolutely there is no reason to redeclare the same variable. But if you want to redeclare the variables, you can declare them based on the scope. There is a separate scope. Separate scope always creates a separate stack frame whenever you compile your code in the memory stack memory. That we will discuss in the next session. I will discuss a lot about that. So, right, within the scope, if you use here, the variables that are printed are different. Outside of the scope, I think OK is not there. Outside of the scope, let me give OK as well somewhere here. Outside of the scope, if you print, it takes the global scope. Inside in this scope, if you print, it takes the nearest variables that are in the nearest scope. That means num1 is 0, num2 is 0, num3, num4, num5 are zeros. OK, as like this, and we can give values called 100, 200. Num5 and num6 are 100 and 200. You can assign values like this. So this is within a scope. It's called shadowing or something. I forgot the name, but that's all. So these are all the values that are printed which are in the scope, this scope, and then when you print the use the print line statement, these are all printed from the global scope. That means not within the scope but outside of the scope, because these variables, the lifetime of these variables is within this particular scope. As soon as they come out of the scope, these are all deallocated from the stack memory. So it uses the bigger scope, which is scope of main, that we call. Okay. And coming to the other one, there is a type called room, actually. Room. Let's say where char is room equal to 95. Sorry, equal to 95. Let me put it as char 1. Where char 2 as room equal to A. Where int 32, sorry, char 3 as int 32 equal to uh, the Chinese characters. I take some Chinese character here. You see that actually there is no data type called character. There is no separate data type as character. These are all character literals actually. So char1 is rune, char2 is rune. So I gave rune as 95 a number. I gave rune as in single quotations A. Char3 as int32 in single quotation a Chinese character. Char4 as rune, which is a Unicode sequence. Basically, there is no separate data type as characters. Rune is there. Rune is alias for int32. That means you see that type rune equal to int32. In fact, you can also create your own type. What I do here is type integer equal to int, and then where num8 is integer equal to some number. You can create, this is an alias. It's an alias. Alias is another name. Just to avoid the error, I just put num8. This is an alias, but you cannot create like this over here because it is declared here. You cannot create here. That's the reason most of these people declare it on top of your program. So they declare it somewhere here as a global scope. So everywhere people can use. It's telling you. You can create like this as well now. Sorry. How can you create? Because this is already created in the global scope, declared on top of main. So everywhere in the main can be used. But just telling you. So rune is nothing but the same thing. Whatever we have done here, rune is that. So I can also create something called type char equal to rune. So rune itself is in 32. We are creating char is rune. So what I can do, where char 5 is char, which is b, like this we can create. So ultimately what is it? There is no special data type called rune or char. There is only built-in type which is called int32. There is only data type called int32. Rune is an alias for int32. There is no data type called byte as well. Byte is a data type which is a alias for uint8. Byte, there is no special type called byte. Byte is just alias for uint8. Rune is an alias for int32. So when I run the program, you see that only the Unicode character values are given here. 95, capital A, which is called 65. This is a Chinese character which is called 30,028. This is another sequence. This is the number. And I give B, which is a 6, which is 66. The values are created like this. You can convert this typecasting. There is a concept called typecasting. In the next session, I will explain the typecasting and other things. But right now, this is how you can create variables. Okay, you can also create byte. For example, you want to create a byte where p1 is byte equal to some value, which is a byte. Byte is nothing but uint8. That means either you can use uint8 as well. No need to use byte. For for characters, you can use int32. No need to use the rune. But whenever you are using rune, it gives a sense that you are working with characters. That is only the difference. Other than that, in all scenarios, if you read that, rune is an alias for int32 and is equivalent to int32 in all ways. It is not a new type, it is just an alias of the existing type. But by convention, people use rune for characters. You can also use characters by using int32 as well. It's not 100% you have to use rune. But as a convention, people use rune for characters. Int32 and rune are both same. See, it's just alias like how I created alias here. It is just how we created a character alias here. There is an alias for another alias which is int32. I created an alias as char. And we created a character as char5 which is b. But whenever I printed, it has printed the value. It has printed the value. You want to convert it, you have to typecast it to string. Then automatically the value is converted as a string, which is a single character here. String is generally collection of characters, but here it is only one character, right? We will see that all these things in a next session. That's what for today. If you have any questions, please do ask me. Otherwise, we can close the session for today.